So good morning students. Already we have discussed about the design of column foundation chapter, slab based procedure. So here comes the problem. So we have taken one section, that is IS-HB 350. So for this section we have to design the slab based panel. So slab based panel is nothing but the column foundation. Under the column foundation we have to design the slab based panel. So first, in this given load 1500 kilonewtons, so load P is equal to 1500 kilonewtons, and FCK is nothing but strength of concrete 20 Newton per mm square. So here we have get the section for IS-HB. IS-HB is nothing but Indian Standard Heavy Beam. 350 at the rate 710 Newton per meter. So this is the properties of IS-HB we will get from table book of steel structures. So we have got the table book of steel structures. The properties of IS-HB are TF, that is nothing but thickness of flange, TW thickness of web, D depth, BF width of flange is the properties 11.6, 10.1, 250, 350. So okay, so we have got the compression strength of steel Fu is equal to 410 megapascals as we discussed in first chapter only. So first step, already we have discussed the steps for slab base. Steps for slab base. So first step, we have to calculate the bearing strength of concrete. So what is the formula for bearing strength is 0.45 FCK. 0.45 FCK. So 0.45 into FCK we have got below the value of compression strength of concrete, that is 20. So 0.45 into 20 we have got the value of 9 Newton per mm square. So first step we have to calculate the bearing strength of concrete. Second step. So what is second step means? Required area of slab. So I have told we should calculate the slab base. So how to calculate the slab base means like this. So required area of slab base formula is nothing but P by 0.45 FCK. So P load already given 1500 kilonewtons. P by 0.45 FCK is nothing but bearing strength. So first step, P by 0.45 FCK is 1500 into 10 cube by 9. 1500 into 10 cube by 9. We have got the value of 0.166 meter square. So 0.166 meter square we can convert into 166 mm square also, no problem. So keep the values in meter or mm. Next, third step, providing square base plate. So we can know. So we can provide square or rectangular base plates. So square base plate means area will be equal, that is side into side. Rectangle means L into B area. So we have taken the square base plate, that is L is equal to B is equal to root A. Why? Because S square is equal to A, that is S is equal to root A. So L is equal to B is equal to root A. So we have got the value of 0.166. So root 0.166 value 408 meters. So we have converted in mm 408 mm. So that is approximately we have taken round figure value 420 mm. So this is the square base plate of side 420 mm. So square is equal. So square means equal in size. So length 420 mm means width also 420 mm. So we have taken providing 420 mm by 420 mm slab base. So this is the third step. So first one bearing strength, second one required area, third one providing slab base plate. So now we have got the fourth step, intensity pressure. So what is intensity pressure? Where the load acts on column. So intensity pressure W is equal to P by A1. Intensity pressure P by A1. So here P means load which is given, but here A1. So there is a difference between A and A1. A means required area, A1 is nothing but provided area. So which is we provided. So we provided area is 420 by 420. So P is equal to P by A1, that is provided area 1500 into 10 cube newtons by provided area 420 by 420, which we get the value of 8.5. So the intensity pressure must be less than bearing strength. Intensity pressure must be less than bearing strength. If it was not get less than value, so we should provide slab base value, we should be increase. Okay, if the value was not less than bearing strength, we should provide the value of base plate must be increased. That's all. So here which is safe. Next, minimum thickness. So this is the minimum thickness. Already we have know the design procedure TS value. So it is in the code book value. So code book TS is equal to thickness of slab base plate is equal to root of 2.5 W A square minus 0.3 B square gamma m naught by F5. So A means larger section, smaller projection. That is the formula of slab length minus BF, width of flange by 2, width of slab minus height of section by 2. So we know the value of length of slab, width of slab 420 by 420. BF from here we will know the value. Height 350. Why? Because ISHB 350 means height H is equal to 350 mm. So we will get the value of A 85 and B 35 mm. Okay, so we know the value of W, A and B and gamma m naught and Fy. We substituted the values in TS. So we have got the value of 26 mm. It must be greater than thickness of flange. It must be greater than thickness of flange, which is properties of ISHB. Otherwise, we should redesign the section from first onwards. Okay, so first step bearing strength, second step required area, third step provided square base plate, fourth step intensity pressure, and fifth step minimum thickness of providing 26 mm. Therefore, for all we have got the value of 420 by 420 by 26 mm thickness base plate. So 420 was the length, width and thickness of base plate of slab base. Okay, so slab base. This is the steps we have taken.